All right, so going over yesterday's homework, number 40, the problem looks like this. We have 2/5 out in front, and then an x plus 1 equals, in this case, g. And we want to solve for x. So remember our steps. The first thing we should always do is the distributive property. So we're going to get rid of that parenthesis. Distributing, we get 2 over 5x plus 2 over 5. Again, following our steps, the very next thing you should do is what? Clear the fraction. If we clear the fraction, we're going to multiply every single thing by 5. Here, the 5's cancel. We have 2x. Plus, here the 5's cancel. We have 2 equals 5 times g is 5g. Now, to get x by itself, we have to first move the term that doesn't have an x. So we're going to subtract 2 to the other side. So we have 2x equals 5g minus 2. And what, of course, do we do last? Divide by 2. Good. So x equals 5g minus 2 all over 2. Any questions on that one? All right. So I had questions on 42. Let's do that one next. For number 42, we have 12 minus 3, parentheses, 2w plus 1 equals 7w minus 3 times w plus 7. First thing, sorry, I said that backwards. 7 plus w. Why don't you write it right? All right, so the first thing we have to do is get rid of the parentheses, so we have to distribute. So we have 12. Here we're going to distribute the negative 3. You always take the sign in front of the number. Negative 3 times 2w is negative 6w. Negative 3 times 1 is negative 3 equals 7w. This time we're going to multiply by negative 3. Negative 3 times 7 is negative 21. And negative 3 times w is negative 3w. Now we collect like terms on each side. On this side, we can put together our 12 and our 3, or negative 3, excuse me. So we have negative 6w plus 9 equals, over here, what can I put together? Good. The 7w and the 3, or negative 3w. So you get a total of 4w minus 21. Now we want to move our w's to this side and then our 9 to that side. So I'm going to subtract 4w from both sides. So we have negative 10w plus 9 equals negative 21. Moving our 9 to the other side, we're going to subtract 9 from both sides. We have negative 10w equals negative 30. And what do we always do last? Divide to solve, right? And we get w equals 3. Lots of steps to that one. Yeah, we will. 244 was the next question I had. On number 44. For number 44, we had 7, a plus 1 minus 3a equals 5 plus 4, parentheses, 2a minus 1. What do we have to do first, you guys? Good, we got to distribute. 7 times a is 7a. 7 times 1 is 7. We're to the end of the parenthesis. We're done distributing. Bring down the negative 3a equals 5 plus. Again, we have to distribute to get rid of the parenthesis. 4 times 2a is 8a. And 4 times negative 1 is negative 4. Now we combine like terms on either side. On this side over here, we can put together our 7a and our negative 3a. We get a total of 4a plus 7 equals, on this side, we can put together our 5 and negative 4. So we have 8a plus 1. What do you want to do next? Devin, what do you want to do? All right. I don't know. Is it? We're not that far. What's the next step? I need to move my A to this side. How do I do that? I subtract my 8 A's to this side. So I have negative 4A. Bring down plus 7 equals. Here, 8A and negative 8A, they cancel. I get 1. Good. Thank you. Subtract 7 to both sides. I have negative 4A equals negative 6. Good. Divide both sides by negative 4. We get A equals positive. Perfect. 3 over 2. All right. 46 was the next question we had. I like question 46. There's lots of steps, and you got to pay attention to which variable you need. In 46, we have capital R times by R1 plus R2 equals R1, R2. And they want us to solve for capital R. So they want us to get this one right here by itself. That's it. Yeah. So what is this parenthesis doing to capital R? It's timesing it, right? And to get R by itself, what do? Divide by it. So we only have to just divide by the R1 plus R2. And that's it. The parentheses will cancel. And we get capital R equals R1, R2 over R1 plus R2. That's all you had to do for 46. Yes, ma'am? No, because 1 you're multiplying and 1 you're adding. Okay? So you can't cancel or anything, right? Other questions? Great questions. All right, let's look at 48. On number 48, the problem is S equals 2 pi r squared plus 2 pi r h. And we are solving for h. We need to get this right here all by itself. So the first thing we should do is move the term that doesn't have an h in it to the other side. How do I move this term that doesn't have an h to the other side? No, let me say that again. This term that doesn't have an h in it, we need to move to the other side. Right now, it's added to that one. How do I get rid of it? There we go. Good. We want to subtract this 2 pi r squared to this side. Can S and negative 2 pi r squared, are those like terms? No, so I've got to write them separate. S minus 2 pi r squared equals, we still have left, 2 pi r h. Now, yep. So since we're trying to get h by itself, and 2 pi and r are all multiplying h, what's the opposite? Divide by 2 pi and r. Whatever I do to this side, I have to do to this side. 2 pi r. And these all cancel. So I get h equals s minus 2 pi r squared over 2 pi r. Do those cancel? No. There is a process happening on the top, so you cannot cancel those. So this is your final answer. Okay? All right, let's look at number 50. On number 50, we have v equals s squared plus 1/2 sh. And we want to solve for h. We want to get this h by itself. All right, so the first thing we should do is clear the fraction, right? which means I have to multiply everything by what? 2. Good. So I'm going to multiply this side by 2, this one by 2, and this term by 2. In the first one, I get 2 times v is 2v equals 2 times s squared is 2s squared. And here, 2 times 1/2 sh, the 2's cancel. And I have plus sh. So now I'm trying to get that h by itself, so I need to move the term that doesn't have an h in it. How do I move this 2s squared? Good. Minus it to the other side. All right. Are those like terms? No, so you got to write them separate. 2v minus 2s squared equals sh. What's the last thing we're going to have to do? What's s doing to h? It's multiplying, right? So we divide to solve. So again, we end up with h equals 2v minus 2s squared over s. Questions before we keep going? No questions. Yes, please. Go ahead, Maya. Okay. Oh. Yeah. If there was an S there, we could have done something with that, but that's not the case. All right, going on to number 52. For number 52, it said, suppose you write and solve an equation to determine the amount of money M you have in your bank account after several weeks. You find that M equals negative 36. What does this mean? What? Yeah, it means you're broke. I agree. It means you're what? You owe them money. You're in debt. Totally agree. Okay? All right, number 54. Number 54, it says find 4 consecutive odd integers with a sum of 184. So first we have to write our equation. We need to understand how we write odd integers, right? 4 consecutive odd integers. So like 1, 3, 5, 7. What is the difference between each one of those? Right? From 1, 3, 5, 7, what's the difference between odd integers? It's 2, correct? Okay, so our first odd integer is going to be x. Our second odd integer is going to be x plus 2. Our third odd integer, 4. There we go, good. Plus, and the last one will be x plus, right? There's 4 of them? Yeah. X plus 6. And you're going to set that equal to what? Tells you in the book that this is equal to 184. That's out of the way. All right. So now we're going to go ahead and combine like terms. How many x's do we have? We have 1, 2, 3, 4 of them. 4x. Plus, combining your numbers, we have 2, 4, and a 6. So 12, right? All right. So now, in order to solve, we're going to first subtract the 12 to the other side. So we have 4x equals 172. Divide both sides by 4. You get x equals, good, 43. So what did we just find? We found 43, but what does that mean? That is your first odd integer, right? That actually fits this one right here. So what's your next odd integer?
Please excuse the interruption. The bathrooms by the gymnasium are temporarily closed. Please use only the bathrooms down by the cafeteria. Thank you.
And what's your final odd integer? 49, good. Okay, so you need all of those answers. I think they said both. I don't know. All right, 56, we have a times 3tx minus 2b equals c times dx minus 2. All right, and we want to get x by itself. So we are trying to move this x right here and that x all to the side, get them by themselves. First thing we have to do is get rid of those parentheses. We do that by doing what? Distribute. Perfect. Distribute. A times 3tx is going to be 3atx. A times negative 2b is negative 2ab equals. We have to get rid of the other side too, right? So we have c dx minus, there we go, negative 2c. All right, now, in our notes, we said the next thing we want to do is move any term with an x in it to the left, right? Minus c dx. Very good. Is that a like term with anything? No. All right, so we have 3atx minus c dx minus 2ab equals negative 2c. Now we have to move the term that doesn't have an x in it to the right. So plus 2ab. Good. So add 2ab to the other side. All right. So I have 3atx minus c dx equals 2ab minus 2c. So now I have x's in two terms. What was the trick we learned yesterday to get two x's or get the x's from two terms into one? What did we do? Undistribute. Very good. We undistribute. We're going to take these x's and put it in front of a parenthesis. So we're going to have x, parentheses, 3at, minus, if I take an x out of this term, cd equals 2ab minus 2c. Now to get the x by itself, what are we going to do? Divide. Got to divide by that parenthesis to both sides. Cancels the parenthesis. And so your final answer is x equals
2ab minus 2c over 3abc, or 3at minus cd.
perfect. Absolutely right. All right, number 58. On number 58, we have a over b, parenthesis, 2x minus 12 equals c over d. And we're trying to get x by itself. What do we always do first? Distribute, absolutely. So let's distribute. A over b times 2x is 2ax over b. A over b times negative 12 is negative 12a over b equals c over d. Now what do we want to do? Okay, you want to times by b? Sure. Let's times everything by b. Clear most of the fraction. So here the b's will cancel. I have 2ax minus, here the b's cancel, 12a equals bc over d. I like it alphabetical. It's not wrong if it's not, but. All right, now what do you want to do? We still have a fraction. Times everything by d. Let's get rid of that one. All right. So we have 2adx minus 12ad equals, and here the d's cancel, bc.
Now you do undistributed.
Oh, we're trying to get x by itself. We only have one x term, right? Good, Maya. We're going to add 12ad to the other side. So we're left with 2adx equals 12ad AD plus BC. Now what's the only thing left to do? Divide by 2 AD. Good. Divide by 2 AD. All right. So get x equals 12 AD plus BC over 12 AD. I'm going to tell you, these do not cancel because it's adding to something on top. So you have to leave it in this form. Yes, sir. Oh, yeah, that's a 2. That's a 2. Yes. All right. Other questions? How we doing? What about 60? How'd 60 go? Bad? Let's do 60. Let's do 60. On number 60. All right, and we want to get x by itself. But we have to first get rid of that fraction, which means we need to times by the denominator. We're going to times both sides by x minus a. Here it cancels x minus a. That's how you clear the fraction, right? We only have a minus c equals m times x minus a. So now what do you think we should do?
Get the x over to...
Well, yeah, but it's in a parenthesis. We got to get rid of those parentheses. We could divide by m. Distribute. I like that idea. Let's distribute. A minus c equals, what's m times x? And what's m times negative a? Good. Absolutely. Now, the term that does not have an x in it, we want to move to the other side. That's the term that has an x in it, so let's get rid of this one, right? So I agree with David. Let's add am to both sides. All right. Is am a like term with anything else? No. So I have am plus a minus c equals mx. Divide by m to get x by itself. And we are left with x equals. Awesome. All right. Yes. Uh-huh. Yes, it would, and then you just have to add a over, but it'd have to stay out of the fraction. Yep, you can do that. There's lots of different forms of each one of these. Anybody else? Okay. All right. So here